We've got great news for you. Whoever brought broken protocols to IETF, ask us. Welcome to Montreal. It's good to see you all. And we are about to start first routing working group meeting. We'll start with administrative. So myself and Chris and Ian Jenkins, secretary, unfortunately couldn't make it. She's following us remotely. Not well, everything said, disclosed is property of IETF. Please read not well before disclosing anything. Our specific to routing working group process, anytime document changes status, so it goes from a document to working group document or progressing to RFC, we will require you to provide IPR statement and disclosures. And unless every author, co-author, and contributor have provided it, the document's not going to progress. Anyone on Jabber? Andrew isn't here. Anyone for Jabber? Okay. Let's look at working group documents. We've got one new RFC 8541 on impact on SPF triggers and delays. 2 documents submitted to OSG. RIP document has been in limbo for almost 2 years, so I contacted authors, and I think we are trying to progress the documents by moving some parts of it into informal. PA multi-homic is almost ready. It's AD follow-up. Graph. Anyway, so the informal document has been in the state for over a year. We are still waiting for Shepherd review. If current Shepherd cannot provide one, would be great if he would communicate it to us, and we'll look for someone else. The FAR-DCN draft as an issue was published to routing working group, is currently progressing through independent stream. So just so you know. The QS model, Young model, is a candidate for working group adoption, and it's going to be presented today. There's a number of existing documents, policy model and the RIB extent model have asked for further progress, so we'll discuss them on the list. And this is pretty much it. Linda?
Hello? Okay, it's working. Good morning. So, okay. Today I'm going to give an update on the net to cloud problem statement and gap analysis. So the update since 104, in last IETF, we got quite a few comments. Some of the comments about how does SD-WAN plays in the network to the cloud data center. So for the problem statement, we specifically add a section how the SD-WAN plays in this domain. Cloud data center itself is really, they can interconnect themselves, and then the problem is for enterprise instantiating their workload into the cloud data center because of the geographic location, the proximity to their end users. the most enterprises tend to instantiate their workload to the locations which is suitable to their usage. So the workload becomes ephemeral, like they change when they can be instantiated in location 1, another time can be instantiated in location 2. So the location been changing, and for many of the service enterprises, their current VPN provider may not have the physical connection to the location they desire. So that's how the SD-WAN plays the important role into dynamically connecting the workload, and especially being able to connect to multiple locations. And we also got comments about the VPC itself. It's called Virtual Private Cloud. What it really is really kind of virtual network dedicated to one tenant. Actually, as one enterprise, they could have multiple virtual private cloud or multiple virtual networks. And on this virtual networks, they instantiate different compute resource or storage resource. So that's how the virtual private cloud being differentiated from the virtual network itself. It's including the compute and also many times virtual functions as well. For the problem itself, we added the clarification on multiple different ways workload can be connected. And many cloud data centers today offers internet gateway and allow users to connect to the workloads through plain internet. Another way is like a virtual gateway or IPsec gateway, so they'll allow them to connect to the workloads through a secure channel. Then another option could be direct connect. They could have physical infrastructures or physical paths they purchase from provide network to connect to the customer gateway. So as from workload perspective, they could just be connected by different methods. So one of the problems encountered by many enterprises is to be able to figure out how this workload actually is connected. If I'm connected through IPsec or if I'm connected through the gateway. So they would like to see different, basically have some kind of visibility from the workload perspective. Also that we also added details on the for the gateway itself. It will advertise all the prefix for this particular client or particular tenant. But the actual workload itself may be actually located in a different locations. From cloud data center perspective, it's all like lumped together as all the reachables through this particular gateway or through multiple gateways. So that's another problem from routing perspective. So for the gap analysis, we had lots of discussions on the mailing list. In particularly is about the gap analysis to the tunneling cap. Tunneling cap, this particular draft has been out in IDR for many years. There's some confusions into it. In particular, what do you mean by remote endpoint? So the tunneling cap itself is really for router to advertise their encapsulation capabilities, right? So in this example, you could have, no, it's okay. So for example, prefix 10.1.1.x, that prefix or VLAN number 3, 10.1.x have the encapsulation of GRE, and VLAN number 3 can be encapsulated by like VXLAN. And then it advertised to all the peers. So when R3 receive a prefix to route to 10.1, they know that, oh, I can use this particular GRE encapsulation. So the confusion part, lots of discussion on the mailing list, to just give a sum up, is about the remote endpoint. The remote endpoint, to people who are familiar with, who wrote the draft, is very clear to them. But to many people, it's kind of confusing. It's real, especially for R1 perspective. When he sent out the update, the remote endpoint is actually himself. And for the receiver, they see the remote endpoint. Okay, it's R1. And another confusion part was as the node themselves, a third party can send on behalf of R1. So like a controller, they want to notify all the relevant parties of encapsulation capability to R1. They can use the remote endpoint to indicate it is actually R1 is where the encapsulation destination should be. So with that being cleared out, and the gaps will be to the WAN point management, because as you see that the eVPN or L3 VPN is all about the client routes distributions, and for the WAN port is connected to the provider network, so it's less of a concern. But for SD-WAN is different. For SD-WAN, the WAN port could facing different ISPs, facing internet, facing trusted network, or facing untrusted network. And the WAN port, if it's in the cloud, it could be a private address, could facing the net, could facing different gateways. So all those WAN properties need to be propagated to the remote peers. And the peers can be in different countries, different continents. And also the route reflect themselves, or the controller themselves, can only be reached through untrusted network. So that part has to be make it clear, very different than the tunneling cap. And that property on the WAN port management, that's not in the tunneling cap. In the past, many of the vendors deploying SD-WAN have been using modified NHRP to basically advertise to the peers what kind of WAN port address they have, what kind of net function they support. But for some of the large deployment, NHRP just doesn't scale well. And another thing is about attachment. So attachment can change, and some of the IPsec tunnels, the WAN port property don't change. So that something has to be addressed. We also clarified this secure eVPN. Secure eVPN has done a good job to basically set up the IPsec tunnels between like a node in a shopping mall, a node in cloud data center, where that is not directly connected or directly attached to the provider VPN's PE. So that IPsec tunnels can be established at different different granularities. The secure eVPN can set up secure tunnel for per PE or per VLAN or per IP or per tenant. So with that draft, our compare is really for the SD-WAN part. Some of the SD-WAN deployment allow, they call so-called internet dropout. So meaning that you already connect to provider VPN. As today's enterprise, you connect to the provider VPN. and you want to expand your capacity, you create an internet port. So through the internet port, you can bypass some of the traffic, either secured or not secured. And the decision is really the local decision. From the CPE's perspective, some traffic have to go through the VPN with SLA. Some traffic can go through the public internet. And this can change depending on the network performance. And most of the SD-WAN deployment have those traffic monitoring based on different applications, and they adjust the policies on the runtime. Another characteristics of the SD-WAN is the location proximity requirement. Some of the deployment require some traffic have to traverse certain locations. Maybe they have specific functions need to perform. Maybe is the regulatory requirement. So that has to be required. And in some of the deployment, you could have a cluster of SD-WAN edge nodes. And from the policy perspective, it could be, has to go through a set of the SD-WAN edge nodes, either one of them. So there's, we call it cluster.
Excuse me, could you wrap up the discussion of the update to the documents? Because I wanted to leave a little time to discuss the documents and how to progress them.
Okay, so this is talking about the additions to the gap analysis. I think this is my last slide. But this one I don't have to talk. So that's it. Actually, that was my last slide of the gap additions to the update.
Okay, thanks. So I'd provided a lot of feedback,
Yes,
specifically on the problem statement document.
Mm-hmm.
And I think Jeff and I are of the opinion that just focusing on that document, that it still needs a lot of work in terms of, clarity. It draws a lot of interesting conclusions, but the means by which it arrives at that conclusion are kind of unclear. But I also had a question looking at this on the fact that you have two documents here. Is there any possibility to combine these two documents?
Yeah, it is absolutely possible.
Because, I mean, in general, in a working group, we see a certain amount of work to publish a document, but once it leaves a working group, once you do working group last call and request publication, there's a huge amount of work that goes on by the AD and the IESG. Okay. And so just the fact of having two documents, if they could really be one document, might help that aspect quite a bit.
Okay, definitely, no problem. Yes, Ali.
Ali suggested Cisco. I like to basically, with respect to this draft, some of the point that you making it as gap and needs clarification. My concern is those points when somebody reads the draft and the tunnel and cap draft, for example, in its entirety, not just one portion of it. Just read the whole draft. Mm-hmm. They are clear. I mean, I didn't find any ambiguity in there, and there are several places that they provide the example. One thing like a remote endpoint, whether the remote endpoint, what it is. I mean, even if the language is ambiguous, the example that it provides, after somebody reads through the example, it makes it clear what it is. And even after that, if the example is not clear, then I would say we need to let the author know to, clarify that example. I don't see why we need to get that clarification done in another draft.
Oh, no. Actually, this is just a little bit update on the email discussions. That clarification is clear. It's not in this draft. Okay, I'm just me myself, because going through lots of discussion, I want to update the group with some clarification. So the main thing is really the gap itself in the document is just to talk about on the WAN port, because SD-WAN WAN port can facing different networks. So that's the gap.
Okay. Then even that, if we try to say there is a gap, frankly, I'm not sure there is a gap, because you go through the tunneling cap, it provides tons of flexibility. I mean, you can do the WAN port that you're talking about. Tunneling cap allows for sending the encapsulation over the WAN port, and the WAN port can be public or it can be private, and then it allows for the recursive resolution of the VPN addresses into the WAN port, and so that you don't have to send the tunnel attribute with every VPN. That's one way of doing it. Another way that it allows you to do that is using coloring. It says you can send the WAN port with the tunnel encap attribute, color it, and then every VPN address you send, as long as it has the same color, it's going to resolve into the same encapsulation.
So could you make this comment on the list specifically regarding
I did.
This document?
Not this document.
No, but I mean, with respect to, in this working group, with respect to this document, I think you're arguing that this document is not actually needed.
So let me ask Linda the question. The email thread that you had, which I responded to, I don't recall whether it was this working group or another working group. Which working group was it to? If it was this working group, that means I already responded.
So actually, tunnel in cap itself, it will be great. You can point it out. We have lots of discussion on the mailing list. However, it didn't address about the WAN port property. When talking about a WAN port property, yes, it's not about encapsulation. It's not about the client route distribution. So the sections you mentioned about recursive and about all those sections, I did go through.
Okay, we have a comment from the IDR chair, I believe, on this.
Ali, the discussion was on the IDR list.
Oh, IDR, thank you.
On this list.
Okay.
I sent, I think that you may have a context difference. I think that it's possible to include in, it's possible to do what you're just saying, right? But the secure VPN draft, which may not be the right context for it, that was what I took, does not have it in it. It's and I think that's what you and Linda are at opposite sides on. Linda's saying it's not specified someplace. You're saying it's possible. Thumbs up to both. We just need to put it someplace and decide where it's going to go. I don't know, and I will turn to the best chairs where it goes.
So I'm closing the lines, and let's move on to Martin.
Linda. Martin speaking as routing AD. Linda, I'm under the impression that the objectives of these two documents was to trigger a discussion on the missing pieces, the gaps, and so on, right?
Can you say that again?
So you wanted to have a discussion on what you feel is missing to achieve what you want to do.
Yes.
Looking at what's happening now, looking at the different lists, I believe there are extensive discussions on the different building blocks that you want.
There are discussions, yes.
It's a question to the group. I'm wondering whether now that the discussions are happening, do we need to publish these two documents?
Oh, I don't know.
Yeah, I don't expect an answer from you.
Okay.
I would expect an answer from the group.
Okay. So the document is to document the problem statements, problems, issues, and for myself, I think is valuable as a history about getting together discussion on the problems and what is missing. And as Chris was saying, that we need more people to putting into the problems. Actually, I was hoping to reach out to some cloud providers to actually go through the document and maybe adding more to clarify them. I think it will be valuable for the community to have this document, whether you publish or not publish, but I think it's valuable to have that. In terms of gap analysis, some of the gaps identified, of course, the drafts, whether tunnel in-cap or secure EVPN, can be enhanced to address those gaps. Then if they do, that's great. That serves the purpose of this document, right? So, but I think the problems is valuable, my personal view.
Thank you.
So I think Aaliyah might be able to provide some perspective on this as well.
Sure, Aaliyah Atlas. So I think that having a problem statement document that looks at the hybrid cloud interconnectivity is extremely valuable, and this document does a lot of those pieces. If the gap analysis, and it's very useful to have us actually thinking and discussing SD-WAN and some of these other constructs that are very commonly used. I'm not sure if a gap analysis is the right endpoint for something to publish. It might be that it transforms, instead from being a gap analysis that sparks discussion, into a recipe book.
Yes.
And that would be useful.
That's what I had in mind, but the recipe book would come afterwards.
Yes.
When you have all the ingredients.
Thank you, Ali.
Kayur Patelarkas. Speaking as a co-author for Tunnel and Caps draft, I just wanted to let you know that refresh is being made as we speak. It's going to be submitted. Version 13 is going to be submitted today. I completely agree with Ali that from a solution perspective, everything is in there. But if you feel something's missing, feel free to send a note to either IDR or routing working group. If you are discussing these documents in routing working group, actually a note for working group chair to make sure that you cross-reference or make sure that they cross-reference IDR in it, because the real work for the standardization happens in IDR. Thank you.
Thank you. Actually, for the 13, I don't know if you have published or not. It would be good.
Linda, let's just let the people at the mic have their say, and then we'll take the discussion on the list.
This is an IDR moment that may help the chairs. We will be discussing these drafts in an IDR session on Wednesday from 13:30 to 15:30. During that time, I will give an overview of the secure VPN, and Ali, and June remotely will be discussing it. Maybe you want to move some of the technical stuff over to IDR regarding that.
Okay, quickly, one last comment.
Very quick. Basically, in terms of the gap analysis, as long as the gap is a real gap, that is perfectly fine to capture in the document. But if it is misunderstanding, it is not a place to put it in a document.
Thank you.
Thank you.
Thank you very much.
And Stuart Bryant is up next to talk about preferred path loop-free alternates.
So if I accidentally say path preference routing, it's because I keep mixing the two up. It's really called preferred path routing. So let me start by giving a quick overview. Some of you may have seen this work spoken about in LSR, but not everyone. So PPR provides a method of injecting paths into explicit paths into a linked state IGP. In the data plane, the packet is mapped to its intended path by its PPR ID. So there's an identifier on the front of the packet that says what the path is, and then it's up to the forwarders. The PPR ID is a single identifier that's put in the packet. So it's just the name of the path. And the format will be data plane specific. So this is a technology that can support IPv6 addresses, IPv4 addresses, MPLS labels, and also, if you want to, MAC addresses, if you want to apply this technology, for example, to Trill or link state bridging or something. There was an interop for PPR yesterday at the hackathon. So how does it work? Say I want to send a packet from A to B to C to D. That's not the shortest path. What I do in the control plane is to inject a data structure that says, this is the PPR ID, and here is the path I want it to follow, A, B, C, D. In the data plane, the only thing that goes on the packet is the PPR ID. And that's true no matter how complex the path. So let's look at how we apply this to fast reroute. So first off, I'm going to consider a simple basic link repair. I've got the this subtopology here. AB, CD is the path I want to go. And I need to deal with an incidence of the breakage of the link BC. So the first thing I do is to assign a PPR ID to this repair. We'll call that C prime. And then I set up the path that I want the packet to follow if BC fails. The path is going to be from B to E to F to G and then on to C. Note that this can be any arbitrary path that I wish to construct for any policy reason that I wish to construct it. So what I do is I encap the packet to C prime, and I push it from B to E and start it on its journey, and it will follow the required repair path. Now, I could, of course, terminate this repair path early. I could drop the packet off in queue space. So if we consider the little subtopology below, I'm going to release the packet at F prime. The path to F prime is from B to E and then F. The PLR is, of course, B still, and I'm just going to encap the packet to F. Now, you also have to think in terms of a fast reroute approach, what you're going to do when the packet arrives at the fast reroute destination. So if it's an IP packet, an SRv6 packet, or a Mac-in-Mac packet, it's all pretty easy. You just take away the outer encapsulation and on you go. If it's MPLS Classic, then we have the usual next hop label problem to deal with. But if we use a model similar to MPLS SR, where we have a well-known compact label space that is associated with the nodes, life becomes a lot easier because you can figure out what the correction needs to be. So we don't need to do the targeted LDP stuff if we can adopt that sort of approach. Note I'm thinking of just using that to steer the packet there, not a full-blown SR solution. Node repair. So this is well known. You have to treat a node repair as K-1 separate failures. You have to also repair to the node itself in case it was a link failure. Each of the repairs can follow, again, any required policy that you want it to follow. And you can have multiple repairs if, from a particular node if that is what your set of policy wants. For example, you might have to send some packets shortest delay and other packets lowest loss or highest bandwidth. So now let's think about traffic engineering. So in this little subtopology, I have a traffic engineered path A, B, C, D. And that's where my primary path is. And I create a traffic engineered backup path, A, E, F, G to D. And what I do is I construct some connectors from the traffic engineered, from the main traffic engineered path to the repair traffic engineered path. So I can join that path at a number of stages. And the reason I do that is that it minimizes the amount of paths I have to inject into the network and minimizes the calculation. So in this particular case, if any of A, B, B, C, or C, D fails, then I have a short path that takes me into a traffic engineered backup path. And the sort of traffic I would want to put on this is traffic with a critical SLA that must use FRR, for example, ultra low latency or ultra reliable traffic, or some IoT slice. or high bandwidth traffic that I don't want to go near the best effort because it's going to damage my normal traffic. So we can make this a bit easier. So there's a draft that's also in LSR that describes the construction of PPR graphs. And what happens here is that the TLVs describe a graph as a series of lists of paths. And a node can figure out where it is in this graph and forward the packet accordingly. In the graph, any node may be a source, but we have to note that a node is a potential source with the S-bit mechanism. And there is, in the PLFA solution, there is just one destination, which has the D-bit set. And the D-bit has that node has a PPR ID associated with it. So we're going to build basically a series of trees. And we'll see the use of that in a moment. So let's look at our simple graph. We've seen this topology before. The key difference is that the repair is constructed as a single graph. So the graph with the PPR ID of D prime has got three sub links in it, if you like, or three subpaths in it. The one EFGD, and then the one B to F, and the one C to G. Notice that all the sources are marked with the S bit in the PPR syntax, and there is only one destination, which is D prime. So we do exactly what we did before. If any of the paths AB, BC, or CD fail, we inject the packet into the PPR graph, and it will arrive at D prime. And this is useful both in the traffic engineered case and actually in the best effort case, because it produces a more compact representation of the repair. And that we'll see in a moment. So, Aliyah may recognize this graph. This is from RFC 7812. And I'm going to look at how we would construct a maximally redundant tree using this technology. So if you recall, a maximally redundant tree is a method of getting a packet through a repair where you're going to do your best shot at having two paths which are redundant, but if you can't find two fully redundant ones, you don't care. That's the best you can do. So look at the two connected graph here. We construct the red tree out of a PPR graph, and we construct the blue tree. And you'll notice that for any failure, the graph constructs a path that one of the two paths will get to the destination. But notice that with PPR, we can construct the graph using any algorithm we want, and we're not constrained to having a uniform algorithm across the network, which was one of the constraints of the MRT approach. And so we can actually construct easily multiple paths, each according to policy, and have multiple repairs, each with its own color. That allows a much richer set of approaches, particularly when we're moving into the world where we need to worry about loss minimization and delay minimization and slices, etc. So let's look at another figure from the MRT RFC. So this deals with the case where there is a constraint that C and G and the link between C and G are a single point of failure. And we can obviously, we can, by demonstration here, construct the MRT pair subject to the SPF constraint, but nonetheless, we can construct it using whatever policy we wish to apply to construct the graph. And so the next thing is we need to consider whether we're going to do this centrally or decentralized, and the answer is we can do both, and we can do whatever suits our problem. In the approach, any node can inject the PPR path, so that can be either the PLR itself creating its own repair paths, or it can be an SDN controller on behalf of the network constructing managed repairs. Multiple nodes can inject the repair for redundancy. So I can multiply connect, and then the IGP flooding mechanism will strip the duplicates and make sure that providing one copy gets into the network, the repair gets to all the nodes, the repair information gets to all the nodes it needs to get to. With this approach, we can use any algorithm for any specific path that makes sense. So that's particularly attractive in an SDN network where I may have some really quite complex policies, or a slice network where I may have some quite complex policies I wish to apply. PLFA is, of course, independent of any other repairing technique. So I can run it ships in the night and use it for specialist cases. I can use it in conjunction with classical LFA if I want. I can use it with any of the approaches to do the thing that it's really good at. Or I can just say, well, why don't I just have one approach? Because it has the capability of finding a repair in any joint, in any network that's not now a cut set. As I mentioned earlier, we can apply it to multiple data planes. The usual ones, MPLS, MPLS-SR, IP, IPv4, IPv6, or Ethernet. Indeed, I can apply it to any data plane in which the topology is known by an entity capable of calculating the repair paths, and it requires no additional data plane services beyond the single-stage encapsulation and decapsulation of a packet at the PLR and decapsulation at the repair target. So advantages: supports any data plane type. The control plane is just the IGP in use. Any repair can be constructed with a single level of packet encapsulation. The repair can be constructed to conform to any policy, whether this is post-convergence, the post-convergence path, which is what TILFA is doing. It can be a TE path, or it can be the policy of the traffic that is being repaired, which is something we don't talk about very much, because if you put traffic into a network with a certain policy, you would really, in my view, prefer to see the repair path conform to that policy. And it's the consistency and loop checking is really easy, which removes a possible problem in some of the techniques. So there's still a lot more to do, and I propose to add more to this work in the next installment. There is some IPR on this, which we will disclose at the earliest opportunity. So does anyone have any questions? Okay, thank you.
Thank you, Stuart. We'll be closely watching progress of main PPR drafts in LSR, since the draft is relying on extensions defined there. Thank you.
So next up is Lei Li to talk about protocol-assisted protocol.
Good morning, everyone. My name is Li Lei, comes from Huawei. And this morning's presentation is a new protocol named PAP. And this protocol is actually to help the existing routing protocols to get more flexible and efficient troubleshooting method. Okay, so before I introduce the detailed information about the new protocol, I just want to, let's talk about the motivation. Why we need to introduce a new protocol for the troubleshooting of the whole network. Actually, in now existing network world, we already have many methods to troubleshooting. One direction is for the centralized troubleshooting, such as we can use MIB to collect some alarm notification and so on to our centralized EMS, or we can use BMP protocol to collect detailed BGP routing protocol information to the centralized SDN controller. And EMS or centralized controller collect all this massive information. It can analyze the relationship of this information and to find the root fault of the network. So we can see if we use the centralized troubleshooting, we can see the advantage is very clear. It's automatically, our operator just sit here and to see our EMS or SDN controller can know why we have some, maybe the root path selected wrong, or maybe the configuration is wrong or anything else, but it's automatically. But the disadvantage is clear also, because we want to get this whole analyze result, we need massive information from the equipments. That means we need to collect all alarm, all logs, or maybe protocol informations from every equipment. That means we need extra cost, extra bandwidth cost, extra CPU cost of the equipment. And second very big disadvantage is actually the lack of the cross-domain information. This cross-domain not means the AS domain or anything else, it's managed domain. That means if we want to get the root fault from the equipment, we need this equipment managed by our centralized EMS or centralized SDN controller. But we know the root from BGP, for example, for BGP, actually, maybe the fault is not from our domain, maybe comes from other operators and so on. So if we just use centralized, we cannot get this information, we cannot get the root fault of this BGP's path selection. So this is the advantage and disadvantage with the centralized troubleshooting method. And another direction is distribute or semi-distribute troubleshooting method. This method is not depends on the centralized EMS or centralized SDN controller. We just think if there have some problems, our engineer, always the operator engineer, will log in the node to see, okay, what the meaning of the, what the matter with the routing table or something else. If this routing table without any problems, we will find where the upstream BGP speaker or anything else to log into another equipment to see, also to see the alarm, the notification, and the routing table information, and so on, and one by one to get the root fault. So we can see this distribute method will not generate extra information, extra messages from the equipment to the centralized EMS or controller, but we also need to very high experience for the engineer to can find the trouble one by one and to know how to get this upstream and let the engineer very familiar with different routing protocols, IGP, BGP, SVPT, and so on. So this, and also the same challenge with the centralized troubleshooting, because we need to log in this equipment. That means the boundary of the management domain is also a challenge for the troubleshooting, for the root troubleshooting. Okay. So for these two, sorry. Okay. For these challenges, we want to introduce a new light protocol named the PAP, Protocol Assisted Protocol. This light protocol to meet all these challenges to help our operators to reduce the experience requirements and to reduce the time, troubleshooting time for the whole network. And this new light protocol, I mean, very light. That means from this protocol, we will not exchange very detailed information about the routing protocol or about some alarms and so on. We just to exchange exactly why, who is the problem, who make the problem, just this information exchanged by this protocol. So the information is very light. The second thing is we use this new PAP protocol to exchange between the equipments. So we don't need a centralized server to collect the information. So, and we don't need massive information from the equipment to the centralized server. But actually, I have said that it's a light protocol, so we need to exchange a little more additional information. But this information is not too much. So the bandwidth and the CPU pressure of the equipment is not too much extra cost. And another thing is this protocol is separated with the assisted protocols. That means the routing protocol is still there. We didn't change anything about the existing network service protocol. We just add a new protocol to a separated protocol to just change the troubleshooting. So when we troubleshooting, we will not impact the existing routing system. And also, it's not based on the engineer's experience because it's automatic, totally automatically. And this is a merit of the new protocols. So this is in our draft. In our draft, we give 2 use cases. One is for BGP, another one is for RSVPT tunnel. Actually, we just defined how to exchange the troubleshooting information in BGP to find the oscillation source, and we defined the use case to show how to help operators to get whose link is failure in some RSVPT tunnels, which one. And this is some details about the PAP's messages, encoding of the PAP messages. And firstly, it's negotiation to negotiate whether you can support or not, and request and reply message to exchange the troubleshooting information. And the notification and the ACK is for the additional scenarios for some special scenario to exchange information. So the main process and the main messages is negotiation and request replies messages. And we think because it's for troubleshooting, it's not like a routing protocol. We need so very high reliability. So we think UDP is enough. And we required the UDP port in this draft. Okay, this is message, and this is a very brief operation to explain how this PAP works. But actually, in last page, I have explained first to negotiate whether you can speak, whether you are a PAP speaker, and whether you can receive and answer this information. And if you're not, if nobody knows that, we can use our traditional troubleshooting methods. It's no matter. And for the data request and reply, I have shows in last slides. We just request whose link is failure in this channel, and then send it to our PAP speaker. If this PAP speaker is the fault, RSVP no. Okay, I am the fault. I have this fault. My link is failure. So RSVPT, this module will tell PAP, and then PAP answer this request to the ingress equipment. So this is the request and the reply process. That means we just ask a question and the PAP speaker will answer. The fault node will answer this question. And so this is the basic operation. Certainly we have some additional operations scenarios. So I don't want to explain too much in this very brief operation explain. If you have interest in it, you can read our draft. Okay, so I'm very fast too, because I find somebody has some plans. Okay.
Yes. Hi, Greg Mirsky, ZT. I think that it would be interesting and beneficial that before addressing troubleshooting, which is a reaction to their failure detection, is that you discuss how the failures being detected. Because I understand that questioning something from your peer neighbor or for upstream is driven by detecting abnormal behavior. So how this abnormal behavior is detected and then what's done. Because first we need to know that we have either path continuity problem or quality degradation or some other abnormal behavior that drives us to conclude that there is situation in a network that requires troubleshooting?
Okay, so I think your question is how to detect the fault or how to detect the problem. I think the PAP is just a protocol, generic channel to between the equipment to let them can exchange the messages. But how about this fault detective is based on the traditional existing protocol, such as if BGP have problems, the BGP will know it, and then that means the BGP will tell our PAP. So this is aided protocol. That means BGP will tell this PAP, and then this PAP speaker will answer the question to the request PAP speaker. So this PAP protocol, just aided protocol, they will not do anything about the detective or anything about analyze. They just give the channel to help different different protocols can exchange the troubleshooting information from our protocol. It's like that. So it's we don't touch anything about the detective. Yeah.
Jeff has the primary observation I'm going to make is that you're trying to troubleshoot various protocols, and the type of things that you'll be troubleshooting each of those protocols will vary based on those protocols. What I'm going to suggest is, rather than inventing a new mechanism to try to actually troubleshoot these things, I would suggest instead that this type of information belongs in something like the IETF Yang model for that protocol, or an augmentation for it, something that actually already contains state relating to that protocol itself, and that existing IETF mechanisms like RESTconf or maybe even GNMI carrying these types of things is a better fit. So I agree this is a nice problem to work on. I would suggest working on it in the existing models that we have.
Sorry. Because it's a little long.
If you like, I will take my question to the mailing list.
Okay.
Okay, Lou Anderson. First, a question to Jeff and Chris. I haven't read the draft. Am I allowed to ask question anyway?
Sure.
Okay, thank you. Can you go back the slides to where it says PAP and then expanded within parentheses?
Which one?
That one. Now, the previous one. That one.
Which one?
Back.
Which one?
It says PAP and then parentheses protocol assisted protocol. That
This
one.
one?
Stop,
Okay.
stop. So, first, I'm not sure that it's a merit to actually add more network-wide data to each and every node. That probably needs to be discussed. But my question is rather on, is that you're doing that, is that what actually enables you to not rely on a centralized server? So the fact that you actually spread out network-wide data in the network, is that what actually enables that you're not relying on one centralized controller?
Centralized is...
I can go back to the list on that one. But if it is, so not relying on the centralized controller, is that actually excluding a centralized controller, or is it a behavior in a state where the centralized controller is no longer working for your particular device? It's two different scenarios. Once you say, we take the centralized controller out, we don't want it, or we have a mechanism that when we have a situation in the network, when the centralized controller is not working in the entire network or part of the network, we don't really need to rely on. We can go to a situation where it actually comes back.
This is Robin from Huawei. So this mechanism, I think this is complementary with the centralized solution. Yeah, I think this may be the different scenario. Yeah, because we think that a centralized solution can have the benefit. But you know that's the traditional the maintenance they always use the CRI. That's why. But you know that's when the failure happens on the router, but this failure happens on other router. So that we need. Yeah.
Okay, then I think I liked it. I want to look at it a bit more before. I have one further question. In BGP, if you have oscillation, do you actually know that you are the source? Probably a question for BGP people, but you had an example thing. Someone responds, I am the oscillation source. And I don't think we actually know. We are just behaving as the protocol says.
I think BGP, because we have a feature about BGP. We can, if we find some oscillation, we can, how to say, it's demanded can.
So let's just do one last
BGP
question here from.
I just want to tell you, BGP know that. Yeah.
Hi, this is Mukul here. Could you please repeat your name? Hello. Yeah, so my question was regarding this PAP, where you have given an example of oscillation, right, to identify an oscillation source. How about detecting black holes, etc.? I mean, when you cannot even forward the request to a neighboring router. That was one question. And the second was, in this case also, you need a centralized entity to initiate and to get that report.
I'm so sorry. Could you repeat your question? Because BGP.
Okay.
So why don't we take this and other questions to the list. Dan has one really quick comment to make, and then everything else is going to the list.
Dan Bogdanovic, you're mixing some service level data with the device level, and those two things are, from a modeling perspective, are incompatible.
Yeah.
So, comment from my side, it would be really good if you would have taken single use case and fully worked it out. For example, the BGP example, you would exchange this information, but you didn't describe what you would do with it.
It's better to have a diagram, a picture to show how the process is better, right? But actually, the details in our draft we have.
I read the draft; it doesn't describe it.
It's not very clear.
It's absolutely not clear because there is no end-to-end workflow of how you would use the protocol.
Okay. I will. I think we will refresh the processing about how
great.
to do it, because we already have some code about this draft, about this protocol. It can work. So maybe the draft is not very too much details about that. We can refresh it.
That would be great. Thank you.
Okay, thank you.
So next up is Donald Eastlake, talking about control and user plane separation for BNG. And just to provide a little bit of context for this, there was a BOF at the last IETF, the because BOF, discussing how the IETF and the routing area should proceed in relation to this. So this is not a working group document, but we have a pretty liberal policy in Rtgwg about presentation. So we're not, say, working on this, but perhaps Martin would like to just provide an update on, what the conclusion of the because BOF at the last IETF was.
Thank you, Jeff. So Martin speaking. I was planning to say that at the end, but no, Jeff.
Yeah, I was thinking maybe
I'm still
people
drunk,
could,
Chris. No.
Maybe people could comment on my presentation after I give it. I don't know.
Yeah, but I'm replying to what Chris just said, and he's laughing because I'm calling him Jeff. Yeah, I'd like to remind the group that this presentation doesn't change anything about the statement I made after consultation with the IESG on the because list, which basically says that until we hear back from BBF who's working on requirements and possibly solutions for in that space, that there should be no work to progress in the IETF stream. And that decision still holds. Thank you.
David?
Thank you. This is Dave Sinecrope. I'm speaking as IETF liaison manager to the BBF. After Donald's presentation, I can give the group a brief update on the progress in the broadband forum.
That would be good. Thanks.
Okay. So this is intended to be a quick, simple presentation, just an update on the status of the draft. His draft name is given here. I'm Donald Eastlake from FutureWay, and these are the other authors of this draft. So, purpose, as I did, going to give a brief background, just in case of people who aren't aware of that, and talk about very briefly on the relevant architecture, what the SCUS protocol is about, and messages it has, and mostly talk about an update on the status of that draft. So, SCUS stands for Simple Control Plane and User Plane Separation Protocol, and I'll explain what that means. So the idea is you have a broadband network gateway, which is providing connection between customer equipment and the internet, usually. So it does authentication and accounting and all kinds of stuff like that. And this is very much focused on the fixed network rather than mobile network. So I'm not talking about cell phones talking to cell towers, but more like residences or businesses that have fixed network connections. So this is obviously very high-level generic, but it's useful, people found, to be able to separate the control plane parts of this network gateway from the user plane. And one of the common ideas is that you can put the control plane in the cloud, making it much more scalable, and you can have the user plane, which probably has the highest bandwidth with lots of bits flowing through, implemented in a more physical fashion. But of course, that's not actually a constraint. There's no protocol reason why you can't have both of these be virtual, especially if you had some customer equipment that had lower bandwidth, or both be physical. So this is, you notice there's sort of these triple lines between the control and user plane here. This is a kind of a more detailed explosion here with the dotted line across the center being the control plane and user plane separation boundary. And those triple lines are because most people have looked at this, see that there being three interfaces. A management interface where you use netconf and yang, service interface, which is kind of encapsulation of some particular control service initiation and control stuff to and from the customer equipment. And then this control interface, which is what we're talking about, might need a new protocol. So SCUS is a lightweight extensible protocol. It's designed to support this control interface for fixed networks. It's focused on that. Runs over TCP. It's currently in production use at over 100,000 customers. And next year expected to be more than 1 million customers actually using this protocol. And as has been mentioned, there was a because BOF at IETF 104. So the IETF is currently awaiting further input from the broadband forum. And a number of liaisons have been exchanged. You can go look in the liaison database to see that, or if you go back to the previous presentations that have been made earlier, IETF, some of those have pointers to the liaisons. So I guess we're anticipating that there'll be a future liaison from the broadband forum, and not expected there'll be any IETF work until that happens. So what is the change? The new version is -06 of this protocol. It's a lot more detailed. It's up from 70 to 127 pages. That's an 81% increase in the number of pages. It's more thorough, and it's closer to the deployed implementations that are actually in daily use by real customers. There's been a reorganization of some of the material, which I'll show briefly. And the additional details include the contents of the messages expressed in a routing Backus-Nauer form, which is an IETF, I don't know if it's actually a standard, but it's an IETF specification for our BNF. Error fields in various messages have been detail to a greater extent what values can appear there. There's a expanded securities consideration section, still not perhaps super big, but anyway, in general, it's a much better, much more detailed draft. So somebody who is interested in this protocol would recommend they look at this latest draft because they'll learn a lot more. Here's how the core specification material was reorganized. You can see some things that were previously one section have been split into multiple sections, and some previous multiple sections have been combined. Like the new organization is a little more logical and straightforward. And just to give sort of a little flavor of the protocol, a couple slides here. The SCUP uses this extensible message format. There's a message header and there's TLVs, not too surprising. Some TLVs can have sub-TLVs in them. It's possible for vendors to construct their own message. It's a vendor-specified message and a vendor-specified TLV. This shows the message header. It's got a type and a message length and transaction ID and stuff. It's pretty much of a request-response kind of protocol. The TLV header format has it's shown as logically having this operation field at the top of the type area. You can sort of consider that to be all be one sort of type field or not. Certain TLVs, there's an operation that can be associated with the TLVs, which is an operation being performed on data blocks that are specified by the within that TLV. So, and here are the different categories of messages as they're divided in this latest version of the draft, and the various different categories of TLVs. So, if you want more information than these three drafts, you should read the 127 pages that are in the draft. You'll learn a lot more than that. So that's all I had to say.
Hi. So Evangelos Halpidis and myself posted a draft which did an analysis of this using FOSSes. The mailing list went dead. I guess what, you're waiting for the BBF interaction to see if this is an IETF work or not?
I'm not sure I heard you exactly, but yes, I don't believe there's any intent for the IETF to adopt any drafts or do anything here until we've heard further from the BBF.
Okay, so it's reasonable for us to continue posting updates to the FOSSes draft.
I think anybody who can post drafts that they want, that they think are of interest and they think that people would like to read, yeah.
All right, we'll post an update then.
Thank you. Thank you. I think David was going, 1 second. Yeah, we'll let David provide an update on the BBF.
You want to come up?
Sure, why not? Just these are sort of independent, not a, yeah. Perfect.
Again, I'm the IETF liaison manager to the Broadband Forum, so I'm speaking with that hat on. Just to give you an idea of the work that was started as a result of the BCOSBOF. The work in the BBF is progressing well. The work there is known as WT459 disaggregated BNG, and you should be able to find a line item on it in the BBF work in progress page. Basically, what's there is the equivalent of a working group document. It's well underway. It contains the architecture, the use cases, protocol functional requirements, and functional nodal requirements. So it's a fairly comprehensive document. The scope of the work is the set of functions that are currently supported by BNGs today. So not just completely fixed, but also dealing with mobile and mobility integration. The document does not get into protocol design. The BBF made sure that that was something that was designed as out of scope, but rather it sets the stage for protocol selection, either this protocol that Donald presented or others. There are others out there. And also, and/or protocol design where gaps are found or a whole new protocol is needed. All right. They've taken the output of the because BOF very seriously. The discussions have been lively, as they were during the because BOF. The BBF, even despite all these lively discussions and the amount of discussion happening around this topic, they're still looking to have a stable document, especially with requirements after their third quarter meeting, which is in early September. And they also appreciate the IETF allowing them time to work through the requirements and all the discussion. Any questions? Okay.
Okay, thank you. Next up is Bing Liu talking about Instant Congestion Assessment Network.
Good morning, everyone. My name is Bing Liu. Today I'm going to introduce a new technology called Instant Congestion Assessment Network for data plane traffic engineering. And please note that this is actually not a personal work of mine. It is a solid teamwork behind, including both solution design and prototype development. For the contents, I'll briefly introduce the targeted challenges, and it is mostly for metro network. And then I'll discuss the ICANN architecture and key technologies, and then some use cases and scenarios. For the challenge one is, as we know, in real network, especially in metro network, the traffic is always heavily unbalanced. Just as the figure shows, some links are highly overloaded, while some links are maybe very light loaded. So the result is the whole network throughput remain a very low level, a huge waste of network resources. And current technologies such as ECMP cannot handle it very well because the ECMP doesn't care about the real situation of congestion either on the local links or on the remote links. And for the UCMP, which involves in the centralized calculation of the multiple paths, the controller will specify a ratio of the multiple paths. However, in the data plane, especially for the segment routing technologies data plane, there's no actual technology to guarantee the data plane ratio aligned with a specified ratio. The main reason is that the router cannot sense the flow size, and it can only dispatch the flow according to the flow numbers, but not the exact flow size. That's the first challenge. The challenge two is that for some general considerations, as we know, some metro network are actually evolving to a more DC-like architecture. So within this context, for example, the cloud migration, this factor will cause the traffic to be more difficult to plan or to predict. And for some specific considerations, if we look into the traffic in a very finer granularity, for example, in milliseconds, although the current traffic planning technology can make sure the traffic is okay in a longer interval, but with a much lower interval, it is still a very serious problem. This is also why the challenge one existing. Okay, so Thank you. So to address those challenges, we proposed a solution, an ICANN solution. So the essential idea is to allow a very fast and continuous measurement between ingress and egress rotors. And before this, we still rely on the controller to calculate multiple paths for each pair of ingress and egress rotor. This could be done in a much slower interval, for example, minutes or even longer days. After that, all the job is handled to the rotor by themselves. The ingress rotor will trigger the path assessment. This requires the egress rotor to collaborate. This is the key technology one, the path quality assessment. And this is done continuously in a very fast manner, milliseconds level. And then the ingress rotor will decide which flow need to be switched to another path according to the measurement result. In order to do this, the ingress rotor need to sense the flow size so that a top-end flow will be recognized. This is something done totally within the rotor. And note that the ICANN solution only requires the ingress rotor and egress rotor to be enabled with such mechanism. The intermediate rotor doesn't need to do anything. Next slide, please. Thank you. And with the same suite of core technologies, but for different purposes, we can come up with 3 use cases. The first one is, of course, the network load balance, but it is a guaranteed balance. For this one, we already have a commercial hardware rotor-based prototype. I briefly introduced in later slides. And the second one is for the SLA assurance for some very high priority services. This results in maybe not a very balanced traffic, but to make sure the most important flows can be guaranteed with SLA. The third one is the high availability, because the measurement itself intrinsically supports the BFD-like functions and can even do more. And the most advantages is that there's no complex configuration for the ICANN as the BFD requires. And the ICANN measurement can not only do the on-off measurement, but also the service degradation measurement. This is also an advantage than the traditional BFD. Now for the deployment scenarios, basically the ICANN is agnostic to the underlying forwarding technologies. Either SRv6 or VXLAN, MPLS can all use this benefit from this technology. Next slide, please. This is the prototype I mentioned before for the network load balance use case. We developed it on the very mainstream router, which is Huawei NE40E. And as the forgot about the laser. As you can see, the topology, there's a 8 router, and we use the traffic generator to push the traffic into the network. And according to the physical capacity, the network should be handled up to 80 gigabyte per second traffic. With the traditional ECMP technology, when the traffic is up to 48 or at most 50 gigabytes, there is a packet drop happening. But with the ICANN system enabling, the throughput can be reached to 61 to 65 gigabytes, which is 30% throughput. A quite good result. Next, please. Yeah, that's the basic idea. We also have some detailed description of the key technologies, including the measurement method and the method of how to switch flows between paths as the backup slides. So you can read by yourself. And yes, please comment.
Emission from Juniper. I have a question. In your example, there's only one ingress router. So that's not the typical case. If you add more ingress routers to the network, and then let's say assume that these ingress routers react to congestions at the same time, right?
Yeah, sure.
There will be a race condition, and
yeah, sure.
There's no guarantee that you're gonna remove the saturation on transit links or nodes in the network.
Sorry, did you ask two questions or just the one question?
Just one question.
Okay.
I mean the example you're giving to.
Okay. There's definitely not only support one ingress router. It is only a very brief representation. But logically, the system works between a pair of ingress router and egress router. But for deployment, you can always deploy multiple pairs of ingress and egress. That naturally could be expanded. Yes?
Greg Rtgwg. So you compare this method to BFD.
Yes, only for the whole ICANN is not against the BFD, but with some extension, we can achieve some function, most of the functions with BFD in specific scenarios. But for the whole system, for the whole idea, it is not mainly against the BFD.
Okay, I have a couple of questions. So you propose to have some active OEM in addition to BFD? Or are you planning to replace BFD?
I guess neither. Actually, if you want to employ the ICANN for better traffic, either for more balanced traffic between multiple paths or to guarantee the very high priority services. And you can get some extra benefit of the BFD functions. So that's the only bonus for you, not to replace the whole BFD for all the scenarios. Did I answer your question?
No, I still kind of puzzled if you are planning to use BFD or you introduce a new active OEM mechanism. What I would invite and would like your feedback. So in the BFD, we'll have a discussion on extended BFD proposal and the whole idea of extending BFD functionality beyond their continuity check. That will be interesting to see how it maps to proposal ICANN. Another reference I would give is look at draft in SFC group on using alternate marking method, which explains how alternate marking method can be used to measure residence time. Because as I understand what you are measuring residence time, the time the packet traverses the node from ingress interface to egress interface. So I think that there are already some work being and thoughts being given to residence time, and actually we do have an RFC on residence time measurement in MPLS networks.
Okay. Would you mind send a mail in the list?
I'll send the email, yeah, to summarize all these comments.
Thank you.
Hey, Andrew Stone, Nokia. You mentioned about microbursts. I'm curious, do you see the solution as being the main target of microbursts, or do you see for longer-term trends of bandwidth utilization?
Sorry, I didn't quite catch
the presentation talked about reacting to microbursts, traffic microbursts, and how ECMP, your flows, when you get microburst situations, you can't handle it. But part of the situation, the solution involves a controller to calculate these paths. Now, depending on the microbursts and the frequency of these microbursts, you might be wasting a lot of cycles, trying to react to these microbursts and actually have these paths being deployed. And by the time they're deployed, they're useless. So I'd be curious to see in the solution how you would handle timing in terms of those microbursts.
Yeah, that's exactly one of the most motivation of why we start this work. You're absolutely right. For the controller, it is almost impossible to handle the macroburst intervals. So we allow a very fast measurement directly on the data plane. In our implementation, the egress router will feedback some measurement results every 3.3 millisecond. And then the ingress router will calculate and do the traffic adjustment every 10 milliseconds. That's our current implementation. And it can handle the macroburst very well, but it's still on laboratory level. We want to do more experiments in real network. So we want to find partners, especially from operators who are interested in this function. Yeah. Thank you.
So does this cover multicast as well, or it's just
please state your name.
Sorry?
Name and affiliation.
Kesavan Tiruvengasamy from Cisco. So does this cover unicast or multicast or both?
Currently, we didn't consider multicast.
Okay. So if it is multicast, you just mentioned that ingress router initiate path assessment, and multicast case usually it's from egress side. When this comes into picture, that's where we will try to pull the traffic. How does it work?
Yeah, I agree. Multicast is more sophisticated. That currently we didn't support it. Okay. We can consider it later. Yeah. Thank you.
David Melman from Marvell. How do you deal with the potential problem of out of flow packet order when you're doing the path switch based on the load? Do you do flowlet based switching?
Yeah, good question. Would you help me to the next one? Maybe the last one, I guess. Next. Yes, the packet order issue and the oscillation issue. Basically, it's due based on the flowlet. And if there's no flowlet, the router will force a flowlet that will break the flow into two parts. The front part will go into a high priority queuing in the router to make sure it will be forwarded as fast as possible. And the backend part of the flow will get into a longer queuing, that to make sure the two packets will transfer in a time interval. There won't be an order issue. And to avoid the oscillation, we will remember which flow had been switched. Then within some time, maybe 5 minutes, we won't touch the flow again to avoid the same flow to be switched back between multiple paths. Thank you.
I have a question to you. So the draft itself is very, very general, has no technical detail whatsoever. So what's your plan with it, to set a framework and then to provide more drafts with more technical details, or what you're going to do with it?
The current draft is only a skeleton of the whole story. And because this is the first time we presented the whole idea in our community, we want to get feedback, especially from operators. Do you think this is a valuable work to do? Do you think it is meaningful for your real network? You want to improve your transmission quality, especially in metro network. We want some more feedback. And if people agree, okay, this is a good thing to do, then for some following up actions, there's definitely some work related to IPPN and some measurement, and maybe also some operational signaling between the routers.
My point, the draft in its current form doesn't have enough details to solicit proper feedback. It would be good if you upgrade it with a bit more data and then ask people
sure.
on the list to.
Sure.
Thank you.
Thanks.
Thanks. Next up, we have Rtgwg talking about 5G transport slice connectivity interface.
Good morning, everyone. My name is Rtgwg. On behalf of my co-authors and myself, I'm going to present this new draft regarding 5G transport slice connectivity interface. Before going through this draft, it's important to note that there has been a project at BBF. It has been accepted a few weeks ago. It's related to this area, and I already talked to Dave Sinocrope and others. It's under discussion how this work and BBF work can collaborate with each other, how they complement each other, and whether or not there is a synergy between them and how it's going to work. So basically, this is ongoing discussion. I'm part of the BBF as well, but it's important to note that at the end, these two should work together and basically provide a bigger picture how IETF and BBF can work together to define this interface. The name is different at BBF, but the concept is more or less the same. This work is related to 5G end-to-end network slicing. This picture tries to depict the whole idea of the 5G network slicing and how the work at IETF, it basically relates to that. The concept of network slicing in this picture, you will see from the left to right, the PowerPoint presentation is better. It has the animation, but anyway, here I'm trying to explain. From the left to right, there are few tenants, BMW, Fiat, public safety. There are tenants or customers which basically want to have logical, independent network from the left, which is the UE, all the way to the right, which is the application. We call each of these logical, independent network end-to-end network slice. In this picture, I have 5 network slices, and each color you can think of the SLA for that specific end-to-end network slice we want. To have each of these end-to-end network slices, we need RAN slice, personality on RAN, we need core slice, personality on core, and at the end, we need connectivity between them, which is basically the discussion of this topic, transport slice. Transport slice are the logical connectivity between various components. So each of these RAN, core, transport needs a controller. It needs a controller to basically control the connectivity that is needed, and at the end, for the end-to-end network slice, we need an orchestrator. The topic of our discussion is, specifically in this discussion, is transfer slice and how it relates to whatever end-to-end, whatever IETF already has, and how we can work together. So this is basically to create one of those end-to-end network slices. Pick one of them in the previous picture, and here I try to basically show the logical steps. These are not by any means a specific rigor steps as I put it in the yellow note, but it's a kind of logical steps from the customer portal all the way to the network, from customer portal, sensor request to end-to-end network slice, company, the Y, I want to create a type of service with a specific SLA, and it goes to orchestrator. Orchestrator creates a profile, and at the end, it goes through some decomposition, as the name suggests. Dave, you have a question?
Yeah, question for clarification. On your slide, it says transport slice connectivity interface. Are you seeing that as a singular interface to control all transport network function, or is that a set of interfaces?
The latter one. It could be a set of functions that, as you will see as I go through it, this interface addresses three functions: automation, aka creation, monitoring and assurance, analytics, and optimization. Whether or not we need one interface to address these three, or we need three or more, basically this under discussion. In my opinion, I think it's a multiple interfaces to address that.
So I wouldn't be wrong to interpret that as a typo, and it should say interfaces.
Interfaces, it should be, yeah, definitely. Yeah, thanks. So step 2 goes to the decomposition, and after that, step 3, 4, and 5, 6 basically try to create various slices on the RAN, core, and transport. The important aspect in this picture is interface 4 and 5, which comes to RAN controller and core controller respectively, are defined in various technical specifications on 3GPP. And interface 6 is basically the discussion of this meeting, that we want to have similar interface for transport, which basically aligned with 3GPP interface 4 and 5. How we can define interface 6 and how this relates to IETF work that we already have, various data models and work that has been done at IETF, how this interface relates to that. Basically, this is the topic of this discussion. I put it in red here to just clarify that we talk about transport slice creation, but that one should be addressed. Every time that we talk about transport slice, we have to think of an end-to-end network slice that I want to create in the network. As a result of that, I need to create transport, RAN, and core. Yeah, Dan, go ahead.
Dan Bogdanovic, why do you create two separate transport slices? And you have like a 5G TSC, and then it goes to the third-party controller that creates another transport slice.
Transport slice is a set of connections. For example, in this specific topic, the right one is addressing connectivity between RAN and core. The left one is addressing the connectivity in RAN, because this is a cloud RAN between, for example, DU and CU. So basically, your endpoints of connectivity are different. In the first one is RAN to core. The second one is inside the RAN equipment between CU and DU. So basically, since we have different endpoints, we have different transfer slices. And I put transfer slices, there is capital. It means that this is not one connectivity. If I have RAN 1, 2, 3, I want to connect it to core 1, 2, basically is a set of connections that I have to do. And basically, this is the whole idea of this picture. Sure. So longest story short, we are discussing the red item in this picture and how it relates to IETF. So these two pictures, I put it there to make sure we clearly see whatever we want to do here is really related to 3GPP. On the left-hand side, top left, any document that you open from 3GPP, you see this picture, and in this one, basically, the transfer slice or connectivity are dashed line, which are not basically defined in 3GPP. And the whole intention is that the yellow box that I put there, transfer slice, is basically defining a dashed line that from 3GPP, they are not addressing it, and we want to make sure we are addressing it the same way that they address core and RAN. And the bottom right picture is basically, if you see it, is very similar to the picture that I showed you in the previous slide. And the whole idea of the transfer slice is defined here. The name is different, but the concept is the same. So the short summary of these three slides are, we want to define an interface between transport slice controller and top orchestrator to basically align whatever we want for a transport similar to the run and code. So this is basically the summary of this presentation and this draft. In this picture, I try to put together, I cannot see. There are top orchestrator, there are 3 controllers, left is RAN, right is core, and the middle is transport. Sometimes if you take a look at the 3GPP, they call the controllers that we are referring to, RAN and transport and core, they call it NSSMF, Network Sub-Slice Management Function. But it's basically the same idea. The important aspect of this picture, I finish this and I go to Dave, is trying to mention that the functionality which are needed for each of these, including the transport, are automation or creation, monitoring and analytics and optimization. So in most cases, when we talk about transport, we talk about creation, but it's very important to make sure we address the other 2 functions as well. Dave, please.
Thank you, Dave Sinacrope Erickson. So again, I'm going to ask my question for clarification, because after you answered and said it was interfaces, that there will be more than one, you went on to explain it as a singular interface.
No, again, very, very, I put interface. This is the typo. It should be interfaces.
So my question is this. Are we looking for one singular transport slice connectivity interface that can accurately represent all the different types of transport technologies that would be under it?
Yes, this is the intention.
So the intention is to have a singular slice interface that represents all the different types of transport technology underneath.
Yes, as I go to the next slide, I clarify that one. The idea here is this interface, similar to 3GPP, are technology agnostic. In other words, how we are implementing. Let's say, I give you an example. I want to connect in the not very simple the 5G or even 4G connectivity. I want to connect eNode B to a core. The connectivity it has, I want to connect RAN to core and with a specific SLA. My latency should be less than 5 milliseconds. My bandwidth should be more than 10 megabit per second. How this one is implemented in the network, implementation or realization, really doesn't change the fact that I want to connect this together. I can connect at the end of the day, I can connect RAN to core through some routers in the middle using layer 3 VPN, or I can simply use routed VPLS, connectivity of layer 2 or layer 3. The connectivity is the same, implementation and realization is different. And this is one of the items that, in my opinion, should work to make sure, for example, we are separating the implementation from the definition of that. And this is basically that abstraction layer that is created. How I can implement the network, maybe in the future there is a new way of implementation of layer 2 or layer 3 services in the network. It should not change this interface. And this is exactly the same for 3GPP. Those interfaces, regardless of how it's implemented, who is the vendor and how detailed is the implementation of RAN and core, they are very generic. I want to connect, I want to create a personality for network slice with some network slice ID. My SLA is this, and very high level. And this is basically aligned with that.
So can I interrupt for a second just to ask perhaps a naive question related to, you also mentioned broadband forum as well earlier in your presentation. So as I understand it, 3GPP has said and has defined the RAN slice interface and the core slice interface.
Correct. It's not one technical aspect, but there are a few of them. Data.
Okay. Have they said we are not doing the transport slice interface?
This is exactly out of...
So can you, I'd like more perspective on this as well, especially since BBF
I'm
was
going to
mentioned.
switch hats. So no longer Erickson, but now the IETF liaison manager to the BBF. What SA5 has done, and it's 3GPP SA5 that are doing the asking. They've set out a widespread liaison asking for the interfaces, the network management interfaces that can be used to facilitate network slicing at the transport level. They sent this liaison, I believe, to IETF, although I'm not exactly sure, but they sent it to at least like 3 or 4 other SDOs that are well known to be involved in the transport space. So MEF, BBF, Study Group 15, etc. Each one of these groups has answered that liaison with what they can offer in terms of network management interfaces. Right. So what I'm hearing Reza mention is that the target interface here is an abstraction of all of these different management interfaces that have been sent back to SA5.
And I have a picture to show here. Maybe I can discuss it more here, but basically a short summary. If Rtgwg didn't define this interface, and based on the discussion that we had with the operators, there is a need to have the same type of the logic interface for transfer slice.
The work that got started in BBF that Reza's referring to is on transport network management slice interfaces, plural. There's been no presumption that there will be one interface to rule them all.
So TF's been working on similar stuff. Have they received, has anyone in IETF actually received it and started working on it?
I can check the statements page, but it would be coming from 3GPP SA5.
Thank you.
Go ahead, please.
I have a comment. My name is Uma from Futureway. So you talked about end-to-end slices and you are focusing on the transport part. What happens if a microwave link between the RAN interface between the E node B or G node B to the cell site router goes bad? So do you care about that? What happens to the end-to-end slicing? So your transport slice is good, but the RAN interface has a problem, like, microwave link is bad or optical is not good. Do you take care of that scenario and you move the slices to the different slice overall, or what do you do there actually?
There are 2 aspects to that one. We can have an off-site discussion on that. One is when we are creating these various RAN, core, and transport slice, and in some document they call it sub-slice or they call it subnet. It's the same thing. One is connectivity between them. They basically don't talk about that. How I connect RAN to transport and transport to core slices to have that real end-to-end from the data path point of view. So this is one aspect. Another aspect is you're talking about how I can make sure that end-to-end network slice monitoring and assurance works. In that case, the end-to-end says it's not working because there is some problem with the RAN, and how that will translate to transport. Maybe they have to change the transport connectivity, or they have to should they change the RAN. In other words, in this picture, neither RAN, core, and transport doesn't understand the end-to-end context. And the box at the top basically shows I have a problem with end-to-end. It should say I have to change the RAN or transport or core or all of them together. So basically, this is a short summary of how it works, connectivity and the assurance at the end-to-end context.
Okay, so the one more comment, actually, this is good answer. Thank you so much. So we have put a draft in DMM working group 3 IETFs back. We presented, and we have been we'll present this Wednesday too, which talks about similar area, but not this actually the slicing aspect and the end-to-end here. But what needs to happen when the mobility happens, when the UE in the 5G network moves from one G node B to another G node B, where the transport, the end-to-end slices of the similar SLAs are there or not after in the target G node B. That aspect is addressed in the DMM working group. That's called transport-aware mobility. There's a draft there. There is a correlation between your thing, what you are doing, and the work that is being done there. I just
if you don't mind, can we talk the offsite and give me more information? Thanks for the info.
Okay, thank you.
Go ahead, Dan, please.
Yeah. When you mentioned here the 5G transport slicing, and you said that those interfaces should be technology agnostic, that you would be specifying some high-level SLAs, because you said here that the characteristics and look into the characteristics. Do you believe that this is the right area to do that? Because what you're talking is more an operator perspective and less of a vendor perspective. And we had some issues with technical service model developments in the past.
Yeah, I don't know whether or not this is the right and the place. And this good question, absolutely. And I want to see whether or not there is some relevance of this work to this working group. And I want to get the consensus of others. But this is a good question, and I'm looking forward to get the answer for that. So I have a few minutes. Let me just finish my thought here, and after that we can take questions if there are. So in summary, what we want to do is the red box here. We want to define that interfaces, there should be S here, to address three things. And all the time we have to think about that three things, not only the creation, but rather monitoring, analytics, and optimization. These are very important aspects that should be addressed. And in my opinion, in previous discussions or some other draft, they don't talk about these two aspects. They just talk about creation and various things that can happen. So, but we have to address three at the same time. So in action, again, if it is PowerPoint, it has the animation, but I'm trying to just starting, we want to create this yellow end-to-end network slice with some specific information. They have a network slice ID 20. In the 3GPP lingo, they call it SNSSAI, but it's basically network slice ID. With for some customer, Honda service type is infotainment, and with some specific SLA. To create that yellow connectivity from RAN all the way to core, orchestrator, which is sitting at the very top, creates RAN and core, and also it creates the transport. Our discussion is the transport, and these are the two things, step 2 and 3. Please take a look at step 2 and 3. This is another aspect that we have to, I think we have to address it at the transport controller. When they receive that abstract connectivity request, how they are going to translate that one to some implementation or realization in the network. I think there should be some requirement to define that, and at the end, number 3 is going to be creating some services, tunnels, paths in the network with a specific technology. Interface number 1 doesn't have any technology. It doesn't say create connectivity between G node V and the RAN using L3 VPN or segment routing, RSVP. It just said do the connectivity with a specific SLA, and at the end, since it's abstract, sitting on top of existing models. In my opinion, this picture basically shows how this work is relevant to IETF. Number 1 is abstract connectivity request, which is sitting on top of number 3, which are existing IETF models for various tunnels, paths, and services. And basically, this is the relevance of this work to IETF. Georgios, please.
Yeah, thank you, Reza. Actually, I was involved in starting this new project in BBF together with Reza and Yang Yonglong from Huawei. So we're actually somehow driven that work. There are some 12 companies that are supporting that work. What I wanted to say is that these two activities will be somehow related, and already what Reza mentioned already, an important point is to identify what are the activities that the BBF should do on this area, because that interface has another name, it's the Mobile Transport Network Slice Instance Interfaces. And here Reza given another name, but we have to somehow synchronize that. But it's important, I think there will be, some activities that need to be done in BBF, and other activities need to be done in IETF, and we should synchronize that. So if this work will continue, it needs to be a synchronization between these two activities.
Yes, thank you for, we will have a discussion to have exactly as Georgios mentioned. And basically, this is the last slide. So we need to have more review discussion. I didn't put it here, but discussion between us and BBF. We have to address in more detail the optimization, assurance, and automation, and finding the information model for that with the requirements, and hopefully the next IETF addressing those, and also the discussion that we have at the BBF. I hope this one was clear, and that's it. This is the end of presentation. Thank you. Go ahead.
Thank you. Dave Sinekrop speaking as IETF Liaison Manager from BBF, or to BBF. Can you make it? Can you elaborate a little bit on how you see the interaction between the two groups and the positioning of this work versus the work in the broadband forum?
In my opinion, again, this is something that at the end of the day, maybe we have to do only one of them. So, but at this time, the way that I see it is we can, from the IETF perspective, we can have to define the requirements, for example, we need for the various technology, which is related to IETF, for example, and that requirement will be basically implemented for the various young model that we want, for example, at BBF. There are two activities. One is defining the requirements, and one is the informational model. So this is the way that I see it at this time, but again, the discussion that we will have in more detail with Georgios and others from the BBF will clarify that one. But at this point, I guess this is the way that I see it. If Georgios wants to add any comments, and if there's any more than whatever I mentioned, please.
With regards to routing to area cooperation, so SCTM defines number of interfaces. You might need a multi-layer network. TS been working on mapping and mapping between different models that you would need. So cooperate with them as well.
Yeah. So I just, before Georgios, sorry, I'm going to present this one at TEAS as well tomorrow, because, for example, for the information model, is it possible that we use the various models that they have and how it's related to that? This is something that
So I'm going to cut this off here so people can get to lunch appointments and so on. We have another meeting tomorrow, Tuesday, at the same time, 10 a.m., but in a different room. Thank you.
Thank you very much.
See you tomorrow. Thank you.